In this section, we're going to talk about rational exponents. When we see the word rational, remember that we're working with ratios. And in the chapter that we just finished up, all of our expressions were those fractions. And this isn't going to be anything that nasty looking, but now we're going to be talking about exponents that are fractions. We know what it means to raise something to the fourth power, or even the negative fourth power, but we haven't yet defined what it means to raise something to, let's say, the 1/2 power or the 3/5 power. So before we start worrying about the exponents specifically, we're going to make some definitions or explain what some things mean. So we're going to say if a to the n power is equal to b, we say that a is the nth root of b. And I switched it from what letters I usually use, so hopefully I don't say the rest of it backwards. A is the nth root of b. So, since 2 to the 5th power equals 32, we say that 2 is the 5th root of 32. Okay, so the 5th root of 32. Since 3 to the 4th power is 81, we say that 3 is the 4th root of 81. Now, since 5 cubed is 125, we say that 5 is we don't say the 3rd root, we say the 3rd root, or the cube root of 125. Okay. Also, since 7 squared is 49, we say that 7 is the square root of 49. So when we're talking about a root of a number, the 4th root or the 3rd root or this cube root or the square root, the 5th root, okay, we're asking what number to that power, to the 5th power or the 4th power or the 3rd power or the 2nd power equals that number. So that's what it means to be a root. So then the next thing we'll say is we'll define in black ink, we'll say the nth root of b, not a, okay. B to the 1 over n power means the nth root of b. The nth root of b. So if we write 32 to the 1/5 power, okay, what we're asking for is the 5th root of 32. Okay. If we have 81 to the 1/4 power, what that's asking in words is the 4th root of 81. Okay, if we want 49 to the 1/2 power in words, that's asking for the square root of 49, and so on. What else do I have? 125. 125 to the 1/3 power is asking me for the cube root of 125. Okay. All right, now, so in words, and you don't have to write down the words when you see this on your paper, and it says find me 32 to the 1/5. In your head, I want you to be thinking this to yourself. That's asking me for the fifth root of 32. And then from the other page before, it says because 2 to the fifth power is 32, then that means 2 is the fifth root of 32. Okay, and numerically we said the fourth root of 81 is equal to 3. And we know the number that we square to get 49 is 7, and the number we cube to get 125 is 5. So the first part of section 7.2 is just getting familiar with these exponents and understanding what the fraction up in the exponent place is asking you to find. Okay, that denominator is asking you to find the root. Okay. So now, sometimes though, we'll be asked to find things like 8 to the 2/3 power, or maybe 81 to the 3/4 power, or maybe 64 to the 5/6 power. Let me come up with one more. 125 to the 4/3 power. Okay. Where the number in the numerator is not equal to 1. Okay. I know that the 1/3 power means I'm after the cube root. Okay, but the 2/3 power, I'm going to have to adjust what I'm thinking about there. So before we tackle these, we're going to kind of go off on what might seem like a tangent for a few minutes, but we're going to kind of get warmed up and ready to go. On the test that we just took from our last chapter and our rules of exponents, if I have a power to a power, I know that means I'm supposed to multiply those exponents together. Now, because of our properties of real numbers, we know that the order that we multiply those numbers doesn't matter. Meaning whether I take 4 times 3 or I take 3 times 4, both of those end up giving me 12. Also, if I was starting with x to the 12th and maybe I was factoring in the next chapter, and I said, well, I need x to the 12th to be some power of x squared. Then I pick the number that times 2 is equal to 12, and I say, this is also x to the 12th. Or maybe I want to put the 2 on the inside and the 6 on the outside. Okay. Because 4 times 3 and 3 times 4 and 2 times 6 and 6 times 2, all of those products are 12. I could write x to the 12th in any of these ways. Also, when I'm looking at fractions, I can write 5 over 9 as the product of 5 and 1/9. Because 5 is 5 over 1, and so 5 times 1 is 5, and 1 times 9 on the bottom is 9. And maybe that's not the only way I could write this as a product, but hopefully you agree that that's one way we could write it. Okay. So 3/5 can be written as 3 times 1/5. Okay. Using this idea at your desk, go ahead and do the same thing with 4/3, with 2/3, with, I don't know, 5 over 6. So pause the video and write it as a product following this pattern. Again, there are other ways we can write each of these as a product, but go ahead and follow this pattern and break those guys down. Okay. So the top number times 1 over the bottom number is what we're going for here. In general, if I have a fraction m over n, I can break it down and write it as m times 1 over n. What we're going to do then is we're going to combine these ideas together. And because this is kind of small, I might have to go back to my single page view here. Okay. Unless I can make these guys grow. Okay. So we're going to do this top one a couple of ways. We said we can write 2/3 as the product of 2 and 1/3. And because 2 times 1/3 is 2/3, I could break apart 8 to the 2/3 power like this. Now my order of operations says we start in the parentheses and we always work our way from the inside to the outside. So this tells me I want to square the 8 first. And then in words, this is asking me to find the cube root of 64. So I think what times itself 3 times is 64. And if I play with it for maybe in the margin, or maybe I type some buttons on my calculator, I'll come up with 4. 4 times 4 times 4 is 64. Okay. Let's see if I can ungroup this guy now. Now, we said earlier it doesn't matter what number's on the inside and what number's on the outside, as long as the product still multiplies together to be 2/3. So if I put the 1/3 on the inside and the 2 on the outside, we know we work our way from inside out. So this is asking us to find the cube root of 8, which is 2. And then I'm supposed to square it, which is 4. It doesn't matter which operation I do first. And which one I do second, I should get 4 both times. But when we come down here to the 81, okay, we can say, well, 3/4 is 3 times 1/4. Okay, and so I can either write it with the 3 on the inside, or I can write it with the 3 on the outside. And if we look at this one, okay, this is asking us to do what? It's asking us to take 81 times itself 3 times. And my calculator might know what that is, but I sure don't. And then once I had that really huge number that's saying take the 4th root of that. Okay. Now, while numerically this will get me the right answer, this is the path I want to take. If we put the fraction inside the parentheses and we take care of it first, the 4th root of 81 is equal to 3. I can do that without pushing any buttons. And then I know 3 times 3 times 3 is equal to 27. So if we put that fraction on the inside and we do the root first and then the exponent, all of our numbers should be manageable. Okay. Now my video is getting kind of long, so when you pause this, try to do these two. And then when you turn it back on, the answers will be there. So don't turn it back on until you're ready to see what's going on. So we put the 1/6 on the inside and the 5 on the outside. 2 is the 6th root of 64, so the 5th power is equal to 32. Here we put the 1/3 on the inside and the 4 on the outside. We said on the page before this that the cube root, ooh, it made small again. The cube root of 125 is 5. Okay, that's what I was trying to do. The cube root of 125 is 5, and 5 to the 4th is 625. Okay, so practice these, and the next video is over rules of exponents.